Okay, lesson one, the checkpoint. I am just using this as a demonstration to show you how I would use the Unit 1 theorem review in conjunction with working through my checkpoints. You can use this document on your checkpoints, on your workbooks, in your exams. It is located in the announcements of this course and it's under the title Unit 1 Theorem Reviews. And so I am just modeling how I would use it so you could have an idea of how it would be helpful for checkpoints. Okay, so checkpoint 1, use the following figure to complete the sentence. The distance between point A and point B is blank. Enter the answer as the number that correctly fills in the blank in the previous sentence. So there's two ways you can do this. You can just count along the number line 1, 2, 3. So you would type in a 3 right here. So there's one way to find distance, and the other way is to use the difference between the 2 points. So difference means subtraction. So we're going to subtract the difference between we're going to subtract the coordinates for the 2 points. So A on the number line is located at -1, and B on the number line is located at 2. And the distance, since distance is a measurement, it has to be positive. We take the absolute value. So we have the absolute value of -1 minus 2. Well, -1 minus 2 is -3. So we would take the absolute value of that, and absolute value of -3 is 3. So there's two different ways you could approach that question. Question 2. Review the following summary of a postulate. Through any three non-collinear points, there exists exactly one triangle. What word, when substituted for the highlighted word in the previous sentence, corrects a possible error in the postulate? Enter your answer as the word that accurately replaces the highlighted word. If the statement is correct as shown, enter the word correct without quotation marks. Okay, so the first thing I'm going to do is I'm going to reference my Unit 1 theorem review, and I'm going to look for through any three non-collinear points. And through any 2 points, nope. If two lines intersect, no. The points on a line can be put in a one-to-one correspondence, no. Okay, so this one says through any three non-collinear. All right, that's the start of it. Points, there exists exactly one plane. Well, it would not be triangle, so you would type in the word plane right here, P-L-A-N-E, and save that. So that is how you would answer question 2. Question 3. Which statement accurately describes a postulate? There is more than one correct answer choice. Select all answer choices. Okay, so if two planes intersect, then their intersection is a point. So I would check back through my postulates, which are the red ones. Nope, that jumps to lesson 2. Okay, so this one is operation of equalities. This one says through any three non-collinear points, there exists exactly one plane. The next one is if two lines intersect, then their intersection is exactly one point. Okay, well, this one says if two planes intersect, so that's off because it should be lines. Through any 2 points, there exists exactly one line. So let's read for our postulate. Through any 2 points, there exists exactly one line. Yes, that one is a correct answer. A plane contains at least 3 non-collinear points. Yes, we answered that in the one in question 2. If two lines intersect, then their intersection is a plane. So if you know these automatically, that is wonderful. If not, use your postulates. So let's look through here. A line. Through any 2 points there exists exactly one line. If 2 lines intersect, then their intersection is exactly 1 point. Okay, and this one is saying it's a plane. So no, because of the plane. A line contains at least 2 points. A line contains at least 2 points. It was said word for word right there in our postulates. So yes, that one is an answer. Okay, and then question 4. Use the following figure to answer the question. Which of the following statements are true? Select all correct answer choices. If only one answer choice applies, select only and the answer choice that applies. So first I'm looking at this number line and I see point A is at -2, point B is at 0, point C is at 2, point D is at 4, point F is at 4.5, and point G is at 6. Now I'm looking at the first question. It says CF, so the distance of CF is equal to the distance of BC. Okay, so let's first go through and find all of the distances for these segments. So C to F would be 1, 2.5. So CF is 2.5. Is that equal to BC? So BC is 1, 2. No. So that one is not correct. AC is equal to BD. So we want to measure AC. Let's count it. A, 1, 2, 3, 4. AC is 4. Is that equal to BD? BD would be 1, 2, 3, 4. Yes. So that one is an answer. Let's check the other ones before we would select only. So then DG is, D starts at 4, so 1, 2. DG is 2. CD is 1, 2 as well. Yes, so that one is it. That means our only option is off the table because we had 2 already. So now CD is less than BC. Okay, well CD was 2 from what we found previously, and BC we found previously was 2 as well. So is 2 less than 2? No, 2 is equal to 2. So AC is less than CG. AC was 4, and CG, I don't think we found that measurement, is what I'm seeing. So let's count it. CG, 1, 2, 3, 4. AC is not less than CG because the distances are both 4. So that's how you would go through. The other way you could go through is by using the coordinate or their location on the number line as well. For example, you could do C is located at 2, so the distance of CF would equal the absolute value of 2 minus 4.5, which would give us an absolute value of 2 minus 4.5 is negative 2.5, and the absolute value of negative 2.5 is 2.5. So that's one way you could use it algebraically if you would like, and you could go through each one that way as well and find the same distances. Question 5. Use the following statement to answer the question. If xy equals 3 and ab plus xy equals 7, then AB plus 3 equals 7. Yes. Which postulate or property does the statement describe? Through any three non-collinear points, there exists exactly one plane. A line contains at least 2 points. Transitive property of equality, multiplication property of equality, reflexive property of equality, a plane contains at least 3 non-collinear points, or the substitution property of equality. So question 5, I'm going to scroll down to our operation properties of equality. The addition property of equality wasn't listed. We need to look for our transitive and check transitive, multiplication, reflexive, and substitution. So transitive property of equality. If A equals B and B equals C, then A equals C. So if x equals 3, if xy equals 3, does 3 equal something else? No, it's not listed, so there's not a transitive property. Multiplication property, we're not multiplying anything, and so there's not a multiplication property. The reflexive property, so let's look back here, A equals A. So is there anywhere it states 3 equals 3 or xy equals xy? No. Okay, so then the substitution property of equality, if A equals B, then A can be substituted for B in any equation. So if xy equals 3, and then I see this equation, and then I see it again, and right where the xy was located, we see a 3. That is the substitution property of equality. So that is our, this is actually our, what's the exact word? It's our addition property of a line segment, but they're using the substitution property of equality to replace xy with 3. Okay, 6. Find AC, CD, and BD. Enter your answers as 3 numbers in the order of AC, CD, and BD. Separate the numbers by commas like this, 42, 53, and 64. Okay, so on this AC, we can count the distance. So that would be 1, 2, 3. So that equals a distance of 3. We could also use the distance formula, which is the absolute value between the distances of where they're located on the number line. So A is -2, that's its, and the difference is subtraction, and C is 1. So -2 minus 1 is -3, and the absolute value of -3 is 3. So there's 2 ways to find AC. Now CD is going to equal, we can count it as well, 1, 2, and again we could use the formula, which is an absolute value of our first coordinate, which was 1 on this number line, and minus, it's our difference, 3. Okay, so 1 minus 3 is -2, and the absolute value of -2 is 2. And the last one we need to find is BD. So B, 1, 2, 3, 4. So BD is going to equal 4. Or, again, you could use the distance formula. B's location is -1. The difference is subtract, and D is located at 3, and -1 minus 3 is equal to -4, and the absolute value of -4 is 4. So when you type in your numbers, you're going to type in 3, 2, 4, just like that. All right, question 7. A blank is a statement proven to be true. Okay, so enter your answer as the term that correctly fills in the blank in the previous sentence. So I'm going to refer back to my Unit 1 theorem review, and I'm going to go through here. A postulate is a statement that is accepted to be true without proof. That's not what it was saying. A axiom is a statement that is deemed to be obviously true. No. A theorem is a statement that is proven to be true. So yes, you would type in theorem for question 7. Question 8, use the following figure to answer the question. Which of the following statements is or are true? So AB is less than FG, so let's find the distance of AB and FG. And we'll compare them. So AB is equal to 1, 2. FG is going to equal, there's a half plus 1, 1.5. So AB is less than FG. Well, is 2 less than 1.5? No, so that's not true. AB is equal to BC. All right, well, let's find the distance of BC. So BC is 1, 2. And so is 2 equal to 2? Yes, so that one is correct. What is the distance of DG? Is DG equal to AB? So let's find the distance of DG. From D, we count 1, 2. That's 2 spaces. So DG is 2. Is 2 equal to AB was 2? Yes. Okay, CF. So CF is going to be located right here, 1, 2.5. So CF is 2.5. And DG was 2. So is 2.5 equal to 2? No. So CD's distance is 1, 2. Is 2 greater than BC? BC was 2, so is 2 greater than 2? No. So that's how you would answer this one. And I'm going to do question 9 because it is the proof. So use the following proof to answer the question. Given A, B, C, and D are collinear points, B is between AC. So I have this line. I have A, I have C. B is between AC. C is between BD. So C is between B and some other point D. So between means in the middle. So I know D has to go on the other side. B and C are both between A and D. So A and D are on our endpoints. B and C are between them. AB equals CD. So this distance is equal to this distance. Prove that AC is equal to BD. So we want to prove that A to C would be the same length as B to D. All right. So AB equals CD, that is given. BC equals BC, reflexive property. A plus AB plus BC equals BC plus CD. Addition property of equality. Okay. The reason why that statement is true is because AB is equal to CD. So that's why that's equal. So they took the reflexive property. They said, okay, this segment right here in the middle is equal to itself. And since we know that AB is congruent to CD or equal to CD, that means that when we add them, it's the addition property of equality. So B is between A and C, given A plus B, AB plus BC equals AC, definition of between. Okay, and then AC is equal to BC plus CD, substitution of property of equality. So where did they substitute? They substituted AB and CD because they were equivalent, given right there. So C is between B and D, that's the given. So then BC right here plus CD is equal to this total length, BD. That's the definition of between. And then we see AC equals BD. And then it would be substitution property of equality. So, then how did they substitute that? They took this statement in 6, AC equals BCD, BC plus CD, that statement, and linked it right here. There was that link. And then they said, okay, well, since those two equal each other, then I can cut out the middleman, and voila, we have AC equals BD. Now it's asking us what change, if any, should be made to the reason for statement 3. There is not enough information to determine if the reason in step 3 is correct. The reason in step 3 should be changed to multiplication property of equality. The reason in step 3 should be changed to reflexive property of equality. The reason in step 3 is correct and should not be changed. And the reason in step 3 should be changed to transitive property. Okay, well, let's scroll down to our axioms and theorems. And let's first just look at the addition property of equality to see if they were correct. And right here, addition property of equality. If A equals B, then A plus C equals B plus C. Okay, so let's talk about what did they do. So right here we have our two different things. AB equals CD. There's the first statement. If A equals B, well, AB equals CD. Then A plus this same thing is going to equal B plus the same thing. So is AB plus BC, are they adding the same thing to both of them? And then CD plus BC. Yes, since they added the same thing, they added the same distance to it, it is the addition property of equality. And so the reason in step 3 is correct and should not be changed. So there is your example for the proof for question 9. And I am going to leave you with a little quote, and this is how I'm going to check for your video submissions. So this quote is by B.C. Forbes. Ideas bring in nothing unless carried out. So there's the quote for your video assignment.